Hi everyone, this video is in connection with lesson 1.3 dealing with the average rate of change using a function. In this particular example, our function is going to be 1 over x plus 11, so generically this is called a rational function because it takes on that shape or that appearance of a fraction. And we want to know how this is how this function is changing over the interval of going from 1 to 1 plus x. What I want you to note here is that these are referring to inputs or x values. So in other words, our input or x values are ranging from 1 to 1 plus h. So the extra layer of complexity here is that you don't have a definite constant value at the end. We have a 1 plus h, or we have an expression. The other thing that I want you to note here is the phrase average rate of change. So when we're asked to find the average rate of change, we're actually investigating what is the slope on this particular range, or on this particular interval that they provided for us. Because what I want you to recall is that the formula for slope was going to be, we had something like m is equal to y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. We're essentially working with this same formula in this problem, and if you refer to your textbook on page, I believe it's like 38, you'll see something similar. The only difference here is that they're giving you something that reads as f of b minus f of a all over b minus a. So I know that this looks slightly different, but what I also want you to note here is that f of b and f of a, these are results or outputs. This is what you would get once you put a number into the function. B and a, in this case, as I've indicated over here, they're x values. So we can say that these are inputs. In other words, these are the values that we would put into a function and evaluate to get the outputs. So in this particular case, B and A are kind of like just like your first choice and your second choice. So I have them highlighted here. So one of my choices in my interval, my lowest value in green is 1, and my highest option to pick from is in purple, which is 1 plus h. So let's go ahead and actually create all of our pieces, and then we will use this formula that I have at the bottom. So to begin, if I want to calculate f of 1 plus h, in other words, everywhere that I see an x value, I'm going to replace it with that expression of 1 plus h. So I'm going to have 1 all over 1 plus h is going to replace the x. I'm just going to put that in parentheses. I do this out of habit, just to indicate to myself that this entire value has replaced that x variable position. And then we have the plus 11. And I'm going to simplify that out, so this ends up simplifying to 1 over h plus 12. And then let's go ahead and look at the first option, so f of 1. So again, if I put 1 in for x, then this would simplify to 1 over 12. So now we can go ahead and we can put it in this formula here. So it's going to get a little bit messy, so I definitely encourage you to maybe try this on your own, pause the video and actually try to clean this up and work this out, and then revisit the video in order to see if you were able to simplify it down appropriately. Or 2, I would go ahead and follow along very carefully, make sure that you are taking notes. Just don't passively watch it. I feel like with regards to if you're actually engaging and writing this down, you're more likely to make some more meaningful connections as opposed to just passively watching the video. All right, so the first portion is going to be f of h plus 1. So I'm going to go ahead and pop that in there. So we know that f of h plus 1, that output is going to be that fraction of 1 over h plus 12. And then we're going to subtract that from our second result, which is f of 1. And we know that's going to be 1 over 12. And then we're going to go ahead and say, all right, our initial input, that was 1 plus h. And we're going to subtract that from our other input, which is going to be 1. So here we're going to go ahead and we're going to start cleaning this up a little bit further. Let's move this screen up a bit so that we have some space. Okay, so I'm going to clean this result up. Okay, so one of the first things that I would note here is that my denominators are not the same. One of them has a denominator of the expression h plus 12. The other one just has a 12 in it. So essentially what I'm going to do is I'm going to multiply the top and the bottom of my purple fraction by a 12, and I'm going to multiply the numerator and the denominator of my second fraction with an h plus 12. In doing this, now each denominator has a 12, and it also has the expression h plus 12. So let's go ahead and clean that result up. So that's going to give me 12 all over 12 times h plus 12 for one of my fractions. And I'm going to subtract that from h plus 12 all over 12 times h plus 12. And then, of course, we don't want to forget what's going on in the denominator here. So we can clean this up. Notice that there's a -1 and a +1 here. So my result is now just going to be an h in the denominator. Okay, so we're going to continue to clean this up. Since I have a common denominator between both of these, I'm going to go ahead and write this as 1. I'm going to consolidate it down. So this gives me on top a 12 minus the quantity h plus 12, and then I have an h. So I am dealing with a complex fraction. We will address that shortly, because we don't really want to keep that around. It's messy. It's harder to kind of keep track of everything. You know, overall it's just less fun, which I'm sure you're probably feeling that right now. So to continue to clean this up, I'm going to focus my attention on what's going on in this top portion of the complex fraction. And I am going to distribute that negative sign to each of those terms inside of the h plus 12 expression in order to get rid of those grouping symbols or those parentheses. So my result, and I won't write this in red because I'm sure that that's not fun to stare at, we'll have 12 minus h minus 12. This is all over that common denominator of 12 times h plus 12. And that is all over h. So in doing this, notice that the positive 12 and the negative 12 will go away. And really, ultimately, what we're doing here is we're just simplifying at this point. There's really nothing else heavy or complex that will be happening here. So now we have negative h all over 12 times h plus 12. And that is also all over h. So the issue here is that it's a complex fraction. We don't want to leave results as a complex fraction. It's like half-baked or half-done. So I'm going to go ahead and rewrite this so that I no longer have to deal with a complex fraction. So I have negative h all over 12 times h plus 12. We know that that's one of the fractions that we had calculated. This division bar I'm going to just turn into the division sign, and this is all divided by an h. Or if you wanted to represent it as a fraction, just so that each one of your expressions here has a clearly defined numerator and a clearly defined denominator, I'm going to write this as over 1. So now we can dip all the way back into our knowledge of how to divide with fractions. And I had learned it from another instructor when I was first starting to teach. She referred to it as skip it. In other words, you leave the first fraction alone, you flip the second fraction, and as a result, it allows you to multiply. So it's skip it, flip it, multiply. So what that means then in this case is we're going to skip the first fraction, and we're just going to write it as we see it. We're going to flip or take the reciprocal of the second fraction, and we are going to multiply. So as you can see here, an h and an h will cross-cancel or cross-reduce themselves out. So my final result is just going to be -1 all over 12 times h plus 12. You could also distribute the denominator out, and you could have negative 1 all over 12h plus 144, but this is the result. We've taken the average rate of change, or in other words, the slope, for this particular function on that interval of x values going from 1 to 1 plus h. I hope that this was helpful in getting you started and getting you thinking about this, and if you do have other questions, feel free to reach out. Thanks.